Okay, so this section of notes, and we're not going to go through all these today. We're just going to go through the first portion of them. Obviously over volcanoes. So we started the semester with tectonics. Second part, talking about earthquakes. Now we're talking about volcanoes. And those three topics are all very closely related. The same forces are responsible for all of those things. So it's fitting that you can study all of those close together because they are so closely related. A couple of these first slides, I'm not going to ask you the questions or whatever. Just kind of go through them pretty quickly. So this first one, it's Mount Fuji, which is in Japan. It's a very iconic volcano. But it shows that there are a lot of really populated areas really close to volcanoes. I know this doesn't look like it's really that close, but it's close enough for a volcano that size. It is close. Here's another example. Mount Rainier in Washington, so just outside of Seattle. Again, Seattle, it's a big city. There are a lot of people who live there. Yet there's a volcano, just right outside the city. What was it in the movie yesterday? A little video, 75 or 80% or something of all volcanoes and earthquakes are around the Pacific Ocean, which we call the Ring of Fire. Just think of all the big cities that are located on the Pacific. And you have, the west coast of the United States. You've got all through Central America, South America, Asia. It's a huge, huge number of people, that are directly affected by these things. Okay, so moving on, we've seen this one several times. So hopefully you have this one down. Magma just being molten rock that's underground. Changes name once it reaches the surface, but when it's still underground in the asthenosphere, we call that magma. Now, there are a couple of different types of magma based on the composition, and that composition will determine what type of volcano forms, what type of eruptions there are. And these are the two different compositions, mafic and felsic. We've seen these words before when we talked about rocks. We were talking about igneous rocks. And it's, two different kind of sets of composition, that makes up magma, and, in turn will make up rocks once that magma cools and crystallizes and solidifies. So mafic composition is the same as basaltic. If you maybe remember, rocks with basaltic composition tend to be very dark, not a lot of silica, so low silica, so basically not a lot of quartz in them. When there's mafic magma, it's very fluid, it flows. Silica acts as kind of a thickener. It makes magma much thicker and chunkier. Because there's not a lot of silica in mafic magma, it flows really well. There's a video that if this were a normal school year, I would have shown everyone. And there's a scientist on there. I think she was a volcanologist, which studies volcanoes. She compared it to honey, so it flows, well. And that's kind of in the picture in the lower right. The other type of magma, the other composition is felsic, which is the same type of magma that makes up granitic rocks. High silica, so a lot of quartz in it. So much lighter colored, much less dense. Because it has a lot of that silica in it, a couple of things happen. Like I said, it becomes more thick. So it's thicker, it's chunkier, it doesn't flow really well. It also leads to a lot of gas inside the magma. So anytime you have gas that's heated up, even if the gas isn't combustible, it's not like propane or natural gas where the gas itself can explode. Even gases that don't burn can become very dangerous when you start heating them up. So that gas can lead to really explosive eruptions. The next one, lava. Again, this is I don't know, probably third or fourth time we've seen this. Plus, not to mention just normal life. It's kind of one of those things you tend to pick up on at some point. This is, molten rock that reaches the surface. So it's magma when it's underground, it's lava once it's at the surface. There's a new word on this slide, tephra. Tephra is kind of a general term for anything that is ejected into the air during an eruption. So that could be, this first term, the blocks. So anything solid, any rock that's thrown into the air. That could be little stuff, dust to pebbles up to huge boulders. There have been reports of there's one movie, there was a guy who happened to be on a volcano when it erupted, and he said the blocks that were coming down around him were about the size of refrigerators, which could obviously be dangerous and harmful to your health. I think he had his leg crushed, but he did survive. So bombs are when molten rock is ejected into the air and it cools either while it's in the air or it hits the ground and it's still molten. And then the last one there is ash. And it's something to think about. I mean, I think at some point we've probably all come into contact with ash of some sort. It's usually paper, wood, something like that. There's really not a lot to it. I mean, if you touch it, it just kind of turns to dust and, it kind of gets your hands dirty, whatever. Volcanic ash is completely different from that type of ash. Volcanic ash is essentially really small pieces and, some of them microscopic pieces of glass. So these are not things that you want to be around if you can avoid it. You don't want to inhale these things. You don't want to breathe these things. It can also, for example, jet engines on airplanes. It can clog jet engines and shut them off. If a plane is to fly through or happens to fly through an ash cloud. So, it can kind of be dangerous in ways that you wouldn't normally expect. And the last one on this little section is this pyroclastic flow. This is something that doesn't happen with every volcanic eruption, but it can happen with certain types of volcanoes. So just like it says, superheated cloud of ash and rock, gas. I mean, the temperatures, can be, 700 up over 1,000 degrees. It can move down the sides of volcanoes, over 100 miles per hour. There was one video, a woman actually survived because she was basically able to get down into a hole where a tree had been toppled, and the pyroclastic flow was melting the plastic handle on a coffee pot that was outside. So, I mean, it's really dangerous stuff. This is one of those things, if there's a volcano in a movie, a lot of times there's a scene where they're driving in a truck and the things, coming down the mountain behind them and they're getting away from it. Odds are that's probably not going to work. It just moves too quickly. But those can be really destructive, really deadly. If anyone's familiar with the city of Pompeii and what happened there, that historically that was caused by a pyroclastic flow. I mean, people didn't have a chance to take shelter or anything like that. It's just too fast. All right, so on to different types of volcanoes. So cone shapes. We always use that term cone just kind of as the volcano itself. The first one is a shield cone. So shield cone, first off, is fed by magma that has mafic composition. So it flows really well. And when the magma reaches the surface, that lava just flows outwards. It doesn't build up, because when I think of a volcano, I just think of it as kind of a stereotypical, it looks like a mountain, has a crater at the top, that sort of thing. And a shield cone, a shield volcano doesn't really look like that, because as that lava flows outwards, it doesn't grow in height a lot. It just flows outwards. So shield cone volcanoes aren't big as far as being tall, but they're big as in covering area. So the largest volcanoes in area, like how much area they cover, are shield cones. But they aren't the tallest. They would be the shortest type. And that's strictly because of the composition of the magma that feeds it. And it gets the kind of the name shield just by kind of the profile of a shield. Kind of broad and low, but there is kind of a curve or a slope to it. The next one is a cinder cone. So cinder cones are fed by magma that has felsic composition. So has a lot of silica in it, a lot more gas, much thicker magma that builds up pressure because it is thicker. A lot steeper. So this is starting to look more like the stereotypical volcano that you might think of. But a cinder cone is primarily made up of tephra that it ejects into the air and then it falls back down. So they're kind of loosely put together. If you've ever like dry sand, salt, sugar, something like that, if you've ever poured any out and it kind of forms a little pile, and then as you pour more on, the pile gets a little bigger, but then it kind of collapses under its own weight. It's kind of like a cinder cone. So these don't become huge volcanoes because they aren't really put together as solidly as some other ones. But it is starting to look more like kind of the traditional volcano. And then the last one, the composite cone. So it's called a composite cone because because of its composition. These are sometimes also called strata volcanoes because the term strata means layer. And these are volcanoes that are layered. If you look at a cross section, you would have a layer of rock and ash, and then you would have a layer of lava, and then a layer of rock and ash and all that, and then lava. And what happens is the way it's layered, it actually kind of forms it so it's really strong. It's really sturdy. It contains a lot of pressure. So because it's fed by magma with felsic composition that has a lot of silica, that has a lot of gas, it's very thick, it builds up a lot of pressure. And since there aren't a lot of places on the volcano that will release that pressure slowly, that pressure can build and build and build until there is an eruption. So that's why composite cones are the most dangerous type. They're responsible for the the largest, most deadly types of eruptions. These would be the big volcanoes like the Mount St. Helens or Etna or Vesuvius or Pinatubo. These are the really big, dangerous ones. You know, the kinds of volcanoes that, with a large eruption, can put ash into the atmosphere that can, lower the temperature of the planet, because the ash in the atmosphere reflects sunlight back into space, so it doesn't warm the Earth. And these are the big ones that, change life on Earth pretty much. All right, I think that's what we're going to stop there for today.